Assalamualaikum warahmatullahi wabarakatuh. Today our group wants to present about linear differential equation, first order and its application. The meaning of linear differential equation is it is a type of differential equation where the dependent variable and its derivative appear linearly. In the first order case, it simplifies to dy over dx plus pxy is equal to qx, where px and qx are the function of the independent variable of x. So below we can see it has a general form. By the general form, we can conclude that the coefficient of a(n)x, a(n-1x) till a0x are function of x, but not of y or its derivative. Okay, now we move on to the first order differential equation. The definition is the first order differential equation involve a function and its first derivative. It relates a function yx to its first derivative of dy and dx. For the general knowledge, it is called first order because it only involves the first derivative. The general form is dy dx is equal to fxy, where f is a function of x and y. Solving this equation involves finding a function yx that satisfies the equation. So the uses of the first order differential equation is essential in describing the rate of change of quantities over time or space. Else is common use in various fields such as science and engineering, for example, in population dynamics, chemical reactions, and motions under gravity.
Okay, the next part. Harvesting renewable natural resource means collecting resource like a fish, wildlife, and a timber in a way that allow them to renew and stay available for the future. Proper management is crucial for keeping the environment healthy, supporting industry, and ensure that these resources don't run out or finish. First order differential equation are useful tool for modeling and improving how we harvest this resource. For instance, like a fish. Okay, the fish. How long the period for the fish to grow up and we can sell it. Okay, and then we move on to the next part, which is the problem statement.
For the problem statement, the needs of the pond fish are increasing day by day as demands for white meat protein is increasing. Determine whether fish population enough for human consumption and whether the species will turn to extinction. For the problem question, the data collected from selected ponds in Gombak, Selangor, Malaysia and Department of Fisheries of Malaysia, they claim that a fish pond can allocate 5 fish for 1 meter square surface area. The area of the pond is 156,100 meter square. K of the pond is 780,500 fish, and the period for the tilapia fish to mature is 6 months, and estimated that 80% of the fish will survive to maturity.
Okay, now I want to solve the question from the previous slide. So for this question, we can use the logistic growth model. That can we write as the P over dt equals to RP 1 minus P over M. Okay, so the variable of P is the we can interpret as the size of population, and the R we can call the rate of survive, the rate of fish survive at the maturity state, and the K from the question we can refer to as the carrying capacity of the population. K. When the parameter H was introduced as obviously function, the logistic growth model which constant obviously is follow as dp over dt equals to rp 1 minus p over m minus ht, when the h is the constant. Okay, so the value of the each variable we can find in the question. So the value of r equals to 0.8 and k equals to 780,500. Okay, so the equilibrium point is also called a critical point or stationary point. At this critical point, the fish population remains unchanged. Okay, to determine the equilibrium point for H constant, we take this value and we sub into the question into the formula. So 0.8 P 1 minus P 780,500 minus H equals to 0. So we get 0.8 P minus 0.8 P over 780,500 minus H equals to 0. So we get 0.8 P minus 0.000000102,498 P squared minus H equal to 0. Okay, so by this equation, we can know the value of A equals to 0.8 and value of B is eh, no. The value of A is 0.000000102,498 and the value of B is 0.8 negative 0.8 and the value of C is equals to H. So we can use the square quadratic formula to find the value of P. So P equals to negative B plus minus square root B square minus 4 AT over 2A. So we sub the value P equals to negative 0.8 plus minus square root 0.8 square minus 4 0.000000102,498 H divided by 2 0.000000102,498. Okay, by letting this expression equals to 0, we have 0.8 square minus 4 0.000000102,498 H equal to 0. Okay, then we get a 0.65 0.00004 0.9992 H equals to 0. So we can find the value of H. So we get the H is 156,100.9098. Okay,
So finally, we are at the conclusion of our slide. So this is the summary of differential equations. First order differential equation and linear equations are important mathematically tools for approximating moving system in a number of fields. This is the definition and form for linear differential equation and first order differential equation. The definition and form for linear differential equation is these are linear derivative of the dependent variable and the form is a in bracket x times with dny over dxn plus until you reach a naught in bracket x times with y equal to gx
And the first order case simplify to dy dx plus pxy equal to qx. And then this is the first order differential equations. Definition will be find the first derivative of a function, and the standard form will be dy over dx equal to f in bracket x comma y. And then this is used in science and engineering mostly. These equations are critical for explaining how things change. And normally ODE is used in renewable resources. They help by controlling the way we collect resources such as timber and fish, ensuring that we never run out and that the environment remains unspoiled. So, in make it more shorter is these formulas help in our understanding and handling of changes, which help us make more intelligent choice. So, if you guys still have some doubt and questions about the topic we just discussed, you guys can refer here. We have two reference book and two link provided that might help you guys to clear your doubt. That's it from us today. Thank you.